Good day, everyone. Um, my name is Mr. Segun, and I'm a mathematics tutor. So today we'll be looking at a topic in mathematics, which is trigonometry. And under that, we'll be talking about or looking at sine rule. Now, the thing about trigonometry is actually a branch of mathematics on its own, which is under geometry. So we'll just take one aspect of trigonometry, which is the sine rule. Alright? So before we get straight into examples and start taking practice questions, so let's see what the sine rule states. So this formula written here is basically what we call the sine rule. So let me quickly give us an exegesis of what the sine rule is. Now, sine rule is used to solve triangles that are not right angled. Now, what do I mean by that? Now, we all know what right angled triangles are, right? So basically, one of the properties of a right angled triangle is that one of its angle is equal to 90. That's what makes it a right angle actually. So if you have a triangle like this, and then you have this, right? So this here, let's say this is A, this is B, and this is C. So this here is a right angled triangle. Why? Because we have an angle 90 degree here. But I want us to know this, that please, sine rule should not be applied to a right angled triangle. We use it for other kind of triangles, an obtuse angle triangle, a reflex angle triangle, and so on and so on and so forth, but not for a right angled triangle. Alright, so most times we get problems or questions involving triangles which are not right angles. So in some questions you might be asked to find the length of a particular triangle, you might be asked to find the angle in a particular triangle, right? So in a case whereby you are given a question or a triangle which is not right angle, how do you solve, what method do you use to solve them? Alright, so we use sine rule. So let's see how we can apply that. But before we go into that, I want to show us something very, very important. Now, we want to quickly look at something which is angles between 0 degree and 360 degree. Now, to explain this so you can understand, now on a Cartesian plane simply is a graph, alright, where you have your x coordinate and your y coordinate. So if you have your x coordinate and your y coordinates and your x coordinates, now what a Cartesian plane does for us is that it divides these angles, that is the angle between, or the angle starting from 0 degree to 360 degree, it divides them into 4 quadrants. Into 4 what? Quadrants. So this is a Cartesian plane, basically a graph, where you have the y coordinate and you have the x coordinate. So what this Cartesian plane or graph does for us is divide this angle into 4 quadrants. So we call this the first quadrant, we call this the second quadrant, we call this the third quadrant, and we call this the fourth quadrant. Now, I will explain what all this means. Now, in the first quadrant, you have angles from 0 degree to 90 degree. we have angles from 0 degree to 90 degrees. So this is how we normally put it. This is theta is less than 0 and 0 is less than 90 degrees. So this simply means any angle you must have in the first quadrant must be greater than 0 but less than 90 degrees. Then for the second quadrant, we have angles of theta is less than 90, less than 180. So this simply means any angle that must fall in the second quadrant must be greater than 90 degrees, because if theta is less than 90, that means obviously if this is 90 degree is less than theta and theta is less than 180. So this simply means if 90 degrees is less than theta, obviously theta is greater than 90 degrees, and which simply means theta also is less than 180. So it falls between 90 to 180. So any angle that must fall in the second quadrant must be from 90 to 180. And then in the third quadrant we have angles from 180 degree to 270. And then in the fourth quadrant we have angles from 270 to 360. So basically this is what a Cartesian plane does for us. It helps us divide these angles into 4 quadrants, right? So that's that. Now another thing you would like to know is we need to know what trigonometric ratios are positive or negative in each of these quadrants. Now I'm sure we are all familiar with the trigonometric ratios we have. We have 6 of them, but for this course we'll just be looking at 3. So we have sine, cosine, and tangent. So basically we still have 3 more. We have cosecant, secant, we have cotangent. But for this course we're just going to look at these 3. Now for sine, all trigonometric ratios in the first quadrant are positive. All trigonometric ratios in the first quadrant are positive. Now please, let me put that down. A simply means or stands for all. A stands for all. All means that every trigonometric ratio in the first quadrant is positive. That sine is positive, cosine is positive, tangent is also positive. Now time will not really permit me to show you how it was gotten, it was derived, because we have to look at some questions and solve them by applying sine. But we'll get to that in a later video. Now moving on to the second quadrant. In the second quadrant, only one trigonometric ratio is positive. And what trigonometric ratio is that? It is sine. Sine is positive in the second quadrant. So also time will not permit me to show you how that was gotten. So this simply tells you that if sine is positive in the second quadrant, every other trigonometric ratio is negative. So that means tan is negative and cosine also is negative. The only positive ratio in the second quadrant is sine. Now moving on to the third quadrant, the positive ratio here is tangent. Now the third quadrant, only tangent is positive. So means sine is positive in the third quadrant and cosine is negative. Sine is negative in the third quadrant and cosine is negative also in the third quadrant. So the only ratio positive in the third quadrant is tan. And then lastly, obviously, which will be what? Cosine. Cosine is positive in the fourth quadrant. So there is actually a method used to find all this, all right, but time will not really permit me to show you how they were all gotten. So quickly, we're going to go straight down into some questions and see how we can apply sine rule, all right, when it comes to problems relating to triangles. So let's go straight down into that now. So we're going to look at some practice questions and we're going to apply sine rule and see how we can solve them. Alright? So, example 1. The question says, in triangle ABC, B is 39 degrees, C is 82 degrees, and A, small letter A, is 6.73 centimeter. Find C. Find C. So now in this particular question, we've been given a triangle ABC. Now we have that angle B is 39 degree, angle C is 82 degree. Obviously this is not a right angled triangle, so that means we can apply sine rule. Now when you have questions like this, the first thing you would want to do is to represent this information on a triangle. Alright, let's do that. So you have A, you have B, you have C. So actually you can decide to switch up the letters. That is not really they are not really specific place to put it. So meaning I can decide to put A here, I can decide to put B here, alright, C here. So the position doesn't really matter, alright? So as long as you can identify that this is triangle A and C. Now, one thing you should take note of in mathematics is that whenever you see capital letters A, B, C, they represent angles. They represent angles. Please take note of that. And whenever you see small letters, they represent lengths. So just like you have in this question now, you can see that small letter A here is used to represent a length, and the length here is 6.73 centimeter. So please take note of that. The small letters represent the length, the capital letters represent the angles. So now that we've established that, let's continue with this diagram. So we have that B is 39 degrees. So I'm going to place 39 degrees here on B. And then we have C is 82 degrees. And then we have that A is 6.73 centimeter. Now, how do you know where A is going to be? Because A here simply is the length, right? So is it going to be here, is it going to be here, or is it going to be here? Now, this is another thing I have to establish. Now, whenever you are given an angle, the length is always or is directly opposite the angle. The length is directly opposite what? The angle. So this is what I mean by that. If this is angle A, this is length A. So the length is always directly opposite its angle. So if this is length angle B, for instance, obviously this will be length B. So please always make sure that wherever the angle faces, that is where the length is. So in this case now, since this is angle A, now since angle A is facing this direction, obviously this will be my length A. I believe that is clear now. So let's put that 6.73 centimeter. Alright, so if this is C, angle C, the length opposite angle C is my length C. The line opposite angle B is my length B. So that's that. Alright, so now that we have gotten or represented this information on a triangle, so let's go ahead and find length C. Why do I say length C? Because this is small letter C, right? And remember I told us that whenever we see the small letter, it represents the length. So that means we are looking for length C. Or if you want to put it this way, you can say you are looking for line AB. Line AB. Because if you want to identify a line, you identify a line with 2 points. So you have point A and point B. So we are looking for C. Or if you don't want to call it C, you can say line A, line AB. Now, I'm looking for line AB. What do? I'm going to apply sine rule. So I'm going to say, using sine rule. And what does sine rule state? Now, before I go on with this, let us know something. Now, there is a condition you have to know before you can use sine rule. Aside from the fact that I said sine rule is only used for triangles that are not right angle. Another condition is that to use sine rule, you must have an angle and an included length. You must have what? An angle and an included length. Now, this is what I mean. If I want to apply sine rule to any trigonometric question or any triangle question, I must be given the angle and the included length. Now, look at this for instance. I have the angle here, 82 degrees, but I don't have the length. I have the angle here, but I don't have the length. Over here, I don't have any angle here, but I have the length here. So in this triangle now, there is no angle and an included length. So what I mean is that if we are given angle C, we should be given length C. That is when we can use sine rule. If we are given angle A, we should be given length A. If that condition is not met, then sine rule is not applicable. Alright? So looking at this question now, I'm going to ask you, look at this very well. You have an angle here. You don't have an included length. You have an angle here, no included length. You don't have any angle here, but you have a length here. Is sine rule applicable here? No, sine rule is not applicable. So please always make sure you look at that first before you use sine rule. So I'll say using sine rule, which is A over sine A is equal to B over sine B is equal to what? C over sine C. So looking at this, since I know that I don't have an angle and an included length, so what do I do? The first thing I have to do here is, since I know this is 82 degrees and I know this is 39 degrees, and I have one more angle left, so I'm just going to use sum of angles in a triangle. Sum of angles in a triangle. And what is sum of angles in a triangle? The total sum of an angle in a triangle is 180 degrees. So that simply means angle A plus angle B plus angle C all must add up to give me 180 degrees. Because it is a triangle, right? So sum of angles in a triangle gives us 180 degrees. So let's go. On angle A, we don't know that now, right? So we just put that as A. But we know the angle on B. The angle on B is what? 39 degrees. The angle on C is 82 degrees. So everything must add up to 180 degrees. So if you collect like terms, A plus 39 plus 82. 39 plus 82. That should give us, this is 9, that should give us 12. This is 121 degrees. So this is A plus 121 degrees is equal to 180 degrees. So all we have to do here is to make A the subject of formula. So over here, I would say angle A is equal to 180 degrees, and this comes over to this side, minus 121 degrees, and then you subtract. Let's see what we have. So once you subtract these two, what do we have? 180 minus 121. So you have this is you have 9. Over here we have 5. So this is basically 59, right? So this is 59 degrees. So that tells us that angle A is 59 degrees. So now this has met the condition of an angle and an included length. Now how do I know? Because now look at this. Angle A now has a value which is 59 degrees, and it also have an included length. So that means sine rule is applicable in this question. So please, before you go ahead and start solving questions on sine rule or any triangle, always make sure it meets these two conditions. First, it must not be a right angle triangle. Secondly, it must have an angle and then its corresponding or included length. So let's proceed with the rest of the question. So let's apply sine rule. Now looking at this, now that we've gotten the angle on A to be 59 degrees, so we have, using sine rule, A over sine A plus B over sine B equals C over sine C. Now since I'm looking for length C, I would have to pick A over sine A and C over sine C. So you just have to pick just 2, right? Now why am I picking A over sine A and C over sine C? The reason is because you use the known to evaluate the unknown. That is what basically in trigonometry, those are the concepts we use. Alright, once you have a known length, known simply means if you are given a particular length, once you know it, you use that value or that information to find the unknown value. So that's just the trick. So now that I know the angle on A and I know the length on A, I can use this information because they correspond to each other or they satisfy each other. I can use that to find an unknown. So the unknown here in this case is C. Let's assume, for instance, we had length B. We knew length B. If we knew length B, I could have still used B over sine B equals to. So, and because the reason I'm not using that is because we don't know length B. So let's go ahead and do that. So quickly, I'll say A over sine A is equal to C over sine C. So the length A, which is given to us from the question, we have 6.73 over sine. Remember, capital letter stands for the angle. So the angle here is 9 degrees. Is equal to C. Right? Now, obviously, we don't know that because that's what we are asked to find, right? So I'm going to place this as C and then sine. The capital letter, which is the angle itself, right? Which is 82 degrees. So at this point, what do we do from here? Alright, since you have two fractions equating to each other and you're looking for an unknown, you simply cross multiply. So when we cross multiply, we have that 6.73, which is this, multiplies what? Sine 82 is equal to C multiplies sine 59 degrees. Okay, so since we are looking for this, alright, so we have to divide both sides by the coefficient of C. So in this case, the coefficient of C is sine 59 degrees. So I would say divided here by sine 59 degrees, divide here by sine 59 degrees. Are you with me now? So this is sine 59 cancels sine 59. So we have that C is equal to 6.73 times sine 82 over sine 59 degrees. So let's go ahead and solve this. We have C is equal to 6.73 times, so let's go to our calculator and punch sine 82. So we have sine 82. Sine 82, from what we have here, is giving us (0.9902), right? That's what we have there, over sine 59 degrees. We have 0.8571. So let's go ahead and punch this and see what we have. So 6.73 times 0.9902. What do we have there? 6.73 times 0.9902. We have 6.664046 over 0.8571. So we have for the numerator 6.664046 over 0.8571. So let's punch that and see what we have as our answer. (6.66 4046 divided by 0.8571. So that is, we have over here, we have C is 7.7751. Let's leave it at that. 51 centimeters. So, but basically, if in the question we're not asked to convert to any decimal place, right? But most times, if you are not given that, what we normally do is we either convert it or leave it in 2 decimal place, right? So say to 2dp, we have, so if you leave this in 2 decimal place, this is going to give you 7.7, this, you round this up, right? So this is 7.78 centimeters. So that is length C. So this is how you use or you apply sine rule to trigonometric questions or questions involving triangles. Alright, so we're going to take one more example and then we'll wrap it up from there, right? So let's quickly get straight into that. So we have a question here, example 2. It says, find the remaining angles of ABC in which A is 12.5 centimeter, C is 70.7 centimeter, and angle C is 116 degrees. So, like we did before, represent the information on a triangle. So, remember, I told us you can decide to put them in any position. So, given here we have A. Since this is the angle, so obviously the length must be directly opposite it. So this will be length A here. So this is 12.5 centimeter. And then length C we have 17.7 centimeter. So if this is angle C, obviously this is length. And then we have the angle on C, 116 degrees. So the question says, find the remaining angles. What does that mean? The find the remaining angle simply means we'll be given one angle in this triangle. The only angle we'll be given in this triangle is 160 degrees. So the remaining angles left to find is just angle A and angle B. So most times they can give you questions that they will not really tell you, or they won't be specific as to what angles you are looking for. So you just have to use your you have to just tick critically to get what, or to understand what they're saying. So we are looking for angle A and angle B. So let's just go straight down into the solution. Now, let me ask us this. From what I explained to us in the previous example, now, can we apply sine rule here? Is sine rule applicable? Remember, I told us there are 2 conditions, right? One, it must not be a right angle triangle. Obviously, you can see that already. It is not a right angle triangle. And also, what's the second condition? That it must have an angle and an included length. So you can see that now we have angle C and we have the length. So that means we can apply sine rule. So let's quickly get straight down into that. So I'm going to start with length A, right? Angle A rather, sorry. I'll start with angle A. So let's start with that. I'll say using sine rule, we have that A over sine A is equal to B over C rather over sine C. So quickly let's go. Length A we have 12.5 centimeter, or just 12.5 over sine A. We don't know that, right? So we just call this sine A. It's equal to, this is C. So we know that C is 17.7 over sine. The angle there is 116. So cross multiply, what do we have here? We have 12.5 times sine 116 is equal to sine A times 17.7. So just like we did before, 12.5, divide both sides by the coefficient of what you are looking for. So which is 70.7. So we have a sine A, which is this, is now equal to everything we have here. 12.5 times sine 116 degrees over 17.7. So we have that sine A is equal to, so let's get our calculators and plot this directly. So we have sine 116. Sine 116, this is 12.5 times sine 116 gives us 0.8987 over 17.7. So let's punch this and see what we have. So we have 12.5 times 0.8987. That gives us 11.23375 over 17.7. So if we should punch this on our calculator, we are going to have 11.23375 divided by 17.7. That gives us 0.6346. So 0.6346. Now, given that sine A is equal to this, remember we are not looking for sine A. We are only asked to find the angle on A. So the angle on A is just A, not sine A. So what do? So we have to find the sine inverse of this. So I'm going to use this space to do that. So we have that sine A is equal to 0.6346. So sine inverse of this, if you punch it on a calculator, so we are going to find the inverse of sine A, which is 0.3646. So let's do that. So we'll say sine inverse, which is sine raised to the power of -1. So if we should punch this on our calculator, angle A should give us 6346 0.6346. So that gives us 39.39 degrees. Alright, so but for the sake of simplification, we're going to reduce this to 2 decimal place, 1 decimal place. So we have that A is equal to 39.4 degrees. So that is the angle on A. But remember, the question tells us to find the remaining angles. So we've gotten A. So that means there is still one more angle left, right? So the remaining angles here are A and B. So now that we've gotten A, we need to find them B. So very quickly, now this is not really difficult. Since you know the two angles, alright, what you can simply do is whenever you have two angles in a triangle and you're looking for the third angle, it's very simple to do. All you need to do is just to do or add up all of them rather, and equate them to 180 degrees. So beautiful. So that will be angle A plus angle B plus angle C must equal to 180 degrees. So A we have 39.4, B we don't know the value of B, but we know the value of C is 116 is equal to 180. If you add these two, you have B is 116 plus 39.4. You have 155.4 is equal to 180 degrees. So you have B is equal to 180 minus 155.4. So what do we have over there? 155.4. 4.6. So angle B is 24.6 degrees. So the remaining angles we have is A is 39.4 degrees and B is 24.6 degrees. So that is the solution to this question. So this is how we can apply sine rule when it comes to trigonometric ratios and triangle or problems involving triangles. So thank you so much for watching. Alright, although there are still more to this because we are still have varied and distances and so on and so forth, right? But we're going to stop here for today. So thank you so much for watching. See you in the next class.